Nice. Where are the marshmallows?
Oh yeah, marshmallow, hot dog.
Yeah.
I don't do burritos though. No?
You heat the whole thing, or you do it?
Yeah, I can only do it a little bit at a time.
So why are you preheating it?
Because it's cast iron.
Yeah.
And that's part of the process necessary. If I don't preheat it, it'll crack.
Doesn't it help draw the welding and penetration?
Yeah, when you're welding it. And we don't weld it with steel, we weld it with nickel. I tell you the price of the welding rods, but Dawn's here, so, you know.
So how many of these have you done? This is the fifth one?
This is the fifth one.
So there were 8 altogether?
3 of them are good.
Yeah.
5 for the other.
I brought a CD for you today.
On the report of 100, did you notice the one that says about red weld still showing?
I was surprised that picture you took. It still showed hot in the picture.
Well, that's why I asked you to do it at that point. It is really hot. These are called arch bars, and they're part of the main frame of the truck. And they were badly pitted in the areas that are shiny now. And what we did was we filled the pits with welding and then ground them smooth. And then we'll put some primer on these. I think this one of them needs a hole drilled a little bit. If you look at these other pieces, which are called brake beams, these are even worse. And what we're going to do in this case is replace the steel, cut out the old bad pieces and put new ones in. What happened, we sent these out to be sandblasted. And when they came back, they had blasted all the rust away, and what was left was the remainder of the solid steel, which wasn't an awful lot.
Looked up on the internet and there is a rod made special for welding cast iron. It's better than nickel, but it's $110 a pound.
Close that door now that you're making all the... Oh, maybe you're not... I probably don't want to... Now what about camera? What's on the camera? They say you look at it? and then grind them as smooth as we can get it. And we'll fill it with epoxy so you'll hardly know it's done. How come all the snow's melting outside?
So stand in the doorway. Unreal, systematic.
Oh.
These go down in underneath the journals, underneath the wheels, one end of the truck to the other. They kind of keep the wheels from falling out. The little marks you see there were cracks that the ASL-100, the people who did the sandblasting and priming on these noticed, and so we will fill those in, weld them up. We just didn't have a chance to do it the other day. Braces for the pylon, the cow catcher. Interesting, one is much larger than the other, and it appears that they must have replaced one at some time or other. In fact, I think the 3 of the 4 that we have are all different. What I'm saying in front of you here is rod that's sort of been cut to length. And from this, for this car and another one we're going to work on, smaller rods are all going to be used for making bolts. Because there's square head bolts, which we're finding are hard to get. They're also of quite a long length. So what we will do is we'll put a nut on one end, weld it on, thread the other end, and make a long bolt. These big rods here are the pins for the swing links, which go in the bolsters of the truck. Those will be cut into 18-inch pieces, have a hole for a cotter pin drilled through on each end.
So the springs just fit right inside?
Yes.
Yeah. And there's like a top and a bottom?
Yeah, these are the bottom.
Yeah.
The top ones, pieces are all right. They look almost the same.
Okay. Okay.
What we're in the process of doing is, at this stage, is an awful lot of cleaning up. Much of the material on the car was rusty, and actually, as rusty parts go, these are pretty good. These are some pulleys that go on the truck. There's a big rod that rides on that, and they're pretty good. We put them in our sandblaster and just blast off all of the crud, and when you get done and come down to it, what remains is in pretty good shape. And these are spacers that go on the equalizers of the truck. This is something to do, goes in the center of the truck. I didn't take it apart, so I don't know exactly what it is. But we have, all of these are about to get primed and painted a very nice shiny black, because we don't want to have this happen again. On the top of this one, for instance, you can see the amount that has been lost due to rust, and if that happens too many times, why, there's nothing left. What really goes is the fasteners. There were bolts through the holes here, the bolts were through the holes here, and they had just rusted away some of them, so there was almost nothing left. I think just force of habit was what was holding 100 together at the end. So anyway, all of these castings are for the trucks, because our object right now is to try to get the trucks back together. Small parts here. One little interesting thing is they all have, find in these, is the letters. This is the part number. It meant something to the American Locomotive company that built this. But it's kind of an old-fashioned style of letter that I kind of like. And that was their casting number. These are little spacers that were in the bolster, which we'll see in a few minutes. So one of our young members, who really was wonderful, he spent all day Saturday and all day Sunday, and he blasted all these parts, so it really moved us way ahead.
And these pieces on
What
the
you
floor
see
here.
down below are equalizer bars. There are 4 pairs, 2 for each truck, and they were, they are run parallel with each other, separated by those castings with the 3 holes in them that hold them apart, and a spring assembly sits right here and another one on that end. And the same thing happened to these that happened to the brake hangers. There's a lot of corrosion in certain areas in there that we have to fill. We have to make a decision as to how much we can do though, because we could spend a very long time welding up every last little dimple, but we're going to do the ones that are that seem to be critical structurally, and we'll stop there. Some of these will be in the inside so you don't actually see them. Here over, they're getting kind of mixed up right now, but anyway, this pile is bolts, either some that we've had in stock, like these nice big ones right here. I can imagine how expensive those, I can't imagine how expensive that would be. This is too long, so what we'll have to do is we'll cut it here, actually right here, and then we'll put more threads on here. And these will go vertically in the truck to keep the top and the bottom together. This one is a piece of threaded rod which we'll cut up into short pieces, and we're going to weld these on the end of the long through rods that go from one end of the car to the other, where the threads have gotten all beat up on the end. Now fortunately, over the years we've collected a lot of bolts, so probably half of these are from our own stock that we've had right along, and then the rest of them we had to buy. This square head, not this particular one, but square head bolts like this are getting harder and harder to find, because they're used principally when you just have a hand wrench on there, an open-end wrench. They don't use sockets on them, and they're kind of slow, so they've done away with them pretty much. But we use them because of their authentic appearance. Now we're going to use hex head here because the Atlantic Shoreline, or York Utilities at the end, had used both. They were using what they had around, so there were hex nuts and there were square or heads and square nuts, so we're going to use the hex nuts because we had those. See, here is a spacer that goes in the center of the bolster. There's a plate that goes on top that's about 103 inches long. Then there's another plate that comes down and goes under and then comes back up. And there are bolts going through them to hold the 2 plates together, and it forms a kind of a truss which goes across the car. And we'll look at the ones, there's one still on the car, and then there's one that we took off, but it's close to the car. So this is a big spacer. It's cast iron and somewhat fragile, believe it or not, and it had cracked, so Dean welded that this morning so that it's all back in one piece. And what he did, what the bolts are for, is we have already drilled holes in the new piece, and he wanted to make sure that this would fit and wasn't welded crooked, so we just dropped the bolts down through the holes in the piece that he made. He didn't think he could do that, and he was afraid that it would be warped and so forth, but there it is, and it worked. What you see in front of you is the remains of the body bolster, which is the main support on the end of the car that holds the body straight across, and it also is through which the motion of the truck, because the motors are down there, is transmitted to the body, which then of course is transmitted to the couplers that are here so that it can pull the car. It's supposed to be quite a strong and substantial structure, bolted down through all the sills. There are 16, 20 bolts or something like that coming down through here that hold the thing to the car, and then it also holds itself together. In the back you see a flat plate that's 3/4 of an inch thick, 8 inches wide, and 103 inches long, which goes from one side of the car to the other. On the very end you can see it's hooked over a little bit, and on the other end it's the same way. Below that is the lower piece, which is flat on either end for 7 inches, bends down for 34, comes flat across for 17, and then goes back up in reverse of that. and it forms a sort of a little bridge or truss which is strong and supports the car, keeps it straight. Below that is the center bearing casting, which has a cup that goes down into a likewise one on the truck, and that's what keeps the thing together. We are in the process of making a new one. We bought the steel, and but we had to take it apart in order to get at things to measure them, and we're going to use some of the castings. The steel, which is the flat material, does not seem to stand up very well with corrosion. In fact, I would say about a third of the weight of this steel is gone in that waste barrel or all over the floor here, in literally sheets of rust that were that thick. The cast iron stands up an awful lot better. Over there you see a side bearing. It's upside down. The shininess on the truck is one that would be pointing up like this. So as the car turns, this whole thing turns, and one is against the other. So when this is on the truck, car I should say, it's right here. It's bolted underneath here. You can see the two holes that it was fastened to, and then there's a piece of steel. Somehow it goes inside of here. There's a spacer. So the casting is actually pretty good shape. We'll just blast that up, paint it, but even in 100 years it has rusted only slightly, whereas the steel in 100 years, as we said, is pretty well gone. Now, we have some metal fabricating capabilities, and we can do a lot of this stuff, but we can't do it exactly the way that Laconia Car Company did 100 years ago, or the way a real big metal shop can do. So what we do is a sort of a compromise. Looking again at the bolster top, you see that block, what appears to be a separate block underneath. What Laconia did was actually in their blacksmith shop with some very powerful device, they first of all heated that sheet red hot, and then they bent it over on itself just like that. But we talked to a modern ironworking place that has infinitely more modern and heavy machinery, and they said that they couldn't do that. So what we will do is on the new piece is we will weld a block right there, and it will give the same appearance, and we'll grind it off so it'll look like it was bent over. That's a compromise we have to make. We had to drill all those holes, and what I did was draw just a simple pattern, and then we used a tool called a rotor broach. And if you want to shut it off, I'll show.
Okay. Okay.
This is a really marvelous tool. You can see it's got shavings on it. That's brand new. It cost about $80. It's cobalt steel. This one is 15/16 of an inch in diameter. It's called a slugger, not because it slugs against things, but because when it drills around a little and leaves a little bit of a core, which is called a slug, and that falls out when the job is all done. Now, we could use a big drill press to do this, but instead what we use is a portable drill with a magnetic base. We did this yesterday. Unfortunately, there's no evidence except this cutter. And we literally set the drill on the plate, and it has a big magnet in the bottom. We turn the current on, and it just sticks there, so that when we push down with the magnet holds it there and doesn't lift up with the pressure that we're putting on the rotor broach. So we drilled all these holes in there yesterday, and then this morning we shipped this plate. There's two on the car, so we shipped two of these plates up to AC Electric in Auburn, Maine, and they're going to sandblast and prime that, and then it'll come back to us in a week. Now the other piece is a little more complicated because it's got a bend in it, and another one here, another one there, 4 bends. And remember, this whole thing is 1 inch thick and 8 inches long. It probably weighs 150 pounds, so it's kind of hard to manipulate. So we've decided to deal with a company called Novel Ironworks, which is down in Greenland, New Hampshire, just south of Portsmouth. And they have it down there right now, and they're going to bend it. We will put all the holes in it except for that one in the center, which they'll do for us. That's where the kingpin comes down through. And then it will come back and I'm not sure whether we're going to send it to AC Electric or grind it ourselves, but anyway, it'll get primed and painted black, and then we'll put the two of them together with the flat straight one across and the bottom one bent, so we can have the spacer and make it into the truss. And then we'll bolt on all of the castings and so forth, and then we'll jack it up underneath the car here, so that when we start taking it apart, we've got something to keep it more or less in line. There's a little interesting thing what you see right here. Why would you want all these wires fastened to this? Well, this is an electric trolley, and the electricity in a trolley car comes from the wire overhead, goes through the motors and the lights and the air compressor motors, whatever else you have, and finally has to get back to the power station. Electricity has to go round and round what they call a circuit. And in order to go back with trolleys, they use the rail as the other wire, so to speak. Copper wire overhead, track on the bottom, form the circuit. Well, in the middle of the circuit is the trolley. And all of the circuits have to go to what they call ground. And the ground, in this case, is where they bolted right on the, they all came from different places. This is probably from the motors. In fact, they were all from the motors. And then it will go down through the center bearing and down through the wheels and back through the rail. So I think that's about all there, unless you have any questions.
All right.
What we're looking at is the right-hand side of the cab. Remember, if you're standing looking at the number one end, this would be the right-hand side. The wainscot on the outside was removed because it was loose. It had paint on all surfaces that we had to get at, and so we decided it would be better to take all the boards off and then put them back properly. There were umpty-dump nails in here, many of which had rusted off, and it was really not very solid. You could push on it and the whole thing moved. Now underneath that wainscoting was this framework, and I was hesitating because I was trying to see what kind of wood that is. I think this is either southern pine or fir, probably southern yellow pine. The vertical pieces are ash. This is what we call a pier post, and when Phil comes closer he can show the rod in the middle there. Kind of a nice assembly. It's quite rigid. We have only really one defect in it, and this was cracked right here. I think we're going to be able to glue this piece back together again. Of course, we have the rot that occurred here and the windowsill at this area we're going to replace. But after it's all done, we'll nail it back on. But we're going to put primer on the back of everything because moisture inside will get out and the paint is apt to crack. It wasn't done that way before, but they were only interested in having the cars maybe 20 years. This ran in Sanford for 42 years, and then it was here for a long time, so we're kind of in it for a lot longer haul. So we have to do some preventative things that wouldn't have been done originally. Yeah, I think we can. Well, here, this shows the back of the trim piece was just raw wood. This is poplar. What we took off was, I think, was a fir. Some of these woods I'm not exactly sure of. But anyway, that's a trim piece, nicely rounded over on the ends. That's the first time I noticed that. I saw it in the pictures. I hadn't actually had my hand on it. They kind of pared the corners off over there. And we'll take this right down to bare wood, sand it, prime it, and then put it back. This is quite salvageable. All right, we're looking at a pier post, which is a 3/4 inch rod, which goes all the way from the header, the sill that runs across over the top of the windows, down here, and remember there were sills running the whole length of the car, and so there was the rod continued down through there. Well, in order to remove the cab and get it down here where it is, we had to end up cutting the sills. Not the sills, but the rod. So what we will do is we'll thread the rod at this point, put a coupling nut, which is a long hexagonal nut, about 2 inches long, thread halfway on here, and then a new piece of steel down through the bottom, threaded on there. Notice the wire that runs through. This is old-fashioned original wire that's 100 and some years old. Whether we'll use that again or not, I don't know. We bought all new, so we probably will replace it. Notice in the posts you can see where the grooves where the windows ran. And we found these in here. I don't know exactly what they are, except they might have been a stop to keep a window from going down too far, and maybe they weren't able to get it. I just thought of that. I'm sure that's what it was.
Yeah.
Keep it from going all the way down in. We're also replacing all the screws. These are iron screws, not steel, and they tend to snap. So we will either, if we can get that screw like that out, we'll put a new one in just slightly longer, or if we can't, we'll put one down here to supplement that, because these tend to snap and then you've got nothing. But it's not bad for 100 years old. It's holding up pretty well.
All right.
What we're looking at is a body bolster. The bolster is this steel affair that goes from one side of the car to the other, and it has several important features. One of which is that it's the strength of this end. This is what holds it all together. There are bolts going up through every one of these sills. There are 8 sills across, so there are 8 bolts, doubled because there's 2 of them in a line, holding the car together. Another function is that this is the center bearing. There's this is the male one pointing down, and then there's a female one on the truck also, and it pivots back and forth, so as the car goes around corners, it guides it, or keeps it from coming off. And it also is where the motors, which are down here, and wheels, which are pulling in this direction, or the other direction, will pull against this, which then pulls the body along. So it has to be quite rugged, because there's an awful lot of force in it. The force from when the car stops, the brakes will be pushing against this. The momentum of the train will be pushing against it also. So very, very strong structure. On the side, what we call side bearings, which are castings that are quite shiny actually underneath, because there's another one on the truck that it will slide against. The 2 of them, they grease them so that they will slide over each other. Now, this is made of 2 major pieces. One is this upper piece here, which is 3/4 of an inch thick, 8 inches wide, and 103 inches long, that goes all the way across the car, and you can see the various bolts, or the remnants of some of the various bolts, and these go up to the top of the sill. Then there's a bottom piece, which is 1 inch thick and 8 inches wide and 100 and some inches long. Flat on the end, angles down to 5.5 inches away here. It's flat at where the center bearing is, and then goes up and flattens out on the other end. So you have bolts at either end holding it together, and then you can see all number of bolts that go through that also hold it together. Like there's a set of them right there. There's 4 of them here, and then there's 2 on the end which have broken off, or I guess we cut them off and we took it apart. Now, one of the problems which we see all the time on this car is the amount of corrosion that has occurred, and much of it is where you have an interface of wood and metal, or metal to metal. Now up here we have some on top. You can see that obviously we weren't going to keep that piece. You can see all the rust right in here. The other is where you have metal to metal, and each sort of contributes to the other. Water has gotten in here somehow, and from here to here is about 3/4 of an inch of rust. Now that will flake off when we take these apart. That'll just fall out or break out in the form of plates of rust. When something rusts, you're bringing in moisture, and you're bringing in oxygen, water, and which forms iron oxide, and it takes up more volume. than the original metal, because you're introducing it's Fe3O4, I think is the chemical composition. So that O4 is what's in here, plus moisture, and that's why it's bigger. And what that will tend to do is snap the bolts off, so that means we're going to have to replace all of this. And we have purchased and fabricated. We will save the cast iron pieces. They don't seem to be affected. It's a different metallurgy between iron and steel, and iron is much less susceptible to rust. So this is the body bolster 4. And in this case, when we take this one out, we'll have a new one all ready to go, except we've got to take off the castings. This is the main frame of the truck, which is just basically a 10-foot by 79-inch rectangle composed of 1.25 inches by, I think it's 4, exactly, 1.25 inch by 4-inch steel. And it's really amazing to me how they, well, I don't know how they actually did it at the Locomotive Car Company. It's amazing to me that they did it, because this is one piece of steel. Before they learned arc welding, somewhere they had to take this bar and wrap it around itself, one bar or maybe more, and then they welded them together by beating 2 pieces together. And I don't know where the weld is. It's really very well made, but this is the main frame of the truck that holds everything else together. This went up to AC Electric, was sandblasted and primed, and we brought it back, and now we will start. This is the basis around which we'll build the whole truck. This is the spring plank. It goes across the truck. In a minute we're going to look at one in place in the other truck. It's supposed to be straight. It's a channel, 8 inches. On either end, the springs, the main elliptic springs, pressed down. And for some reason there was so much strain on it, and this is so badly rusted that it bent. Now they added a piece of 1-inch thick steel on either side, supposedly to help keep it straight. Well, it didn't work. So we've made new ones, and they're presently being sandblasted and primed. There was a block of wood here and another block on the other side, and then on that, the spring set. This is the some of the siding from the right-hand side of the cab. It has nothing on the back, as you can see, but we've removed a number of coats. This is a before. There's probably half a dozen coats of paint on that and down in the grooves, and the only way we can really do justice to this is to take the thing off and take it apart. Not only to replace the nails, as I said earlier, but because we really want to get down inside, and then we'll do the back. This is quite a light wood. I think it's either southern yellow pine or fir. That was not common. Usually they used poplar for the siding, but this is a different kind. So we're scraping it all off. A little bit of the trace of the red that was used in there, but mostly what we find is green. So I think that's it.